Great, welcome everyone to today's webinar. My name is Marie Latulippe and I am the Director of Science Programs at the Institute for the Advancement of Food and Nutrition Sciences, or IFNS. And it is the Low and No Calorie Sweeteners Committee of our organization that is bringing you this webinar today. And this is the next in our series that is focused on clarifying the science around low and no calorie sweeteners. So this webinar is approved for 1 continuing education credit through the Commission on Dietetic Registration. And after the webinar, we'll send a really brief survey to all the participants so you can access that certificate. So a quick note for those of you that may not be familiar with IFNS, we are a nonprofit scientific organization that advances food safety and nutrition science for the benefit of public health. And the way we do that is we bring together the intellectual contributions of scientists from industry, government, and academia, and together they decide what the research questions of common interest are and how they might be addressed. And our operating philosophy at IFNS is that including diverse perspectives in discussions is fundamental to the development of credible science and science that benefits the entire food ecosystem. So getting into the logistics here, this slide shows the control panel. And the first item to note is that orange arrow at the top allows you to collapse the control panel to give you a better view. And then you will also see a question box. So we encourage you to type your questions in there throughout the presentations. Those questions are only visible to the staff, not the other attendees. And then after the presentation, we'll go through a Q&A dialogue period and get back to those questions. So here on the next slide here, you can see our program for today. And the objective is to offer some details about what the ADI for low and no calorie sweeteners is, including a little bit about how it's calculated and how to use it, both in research and in interpreting research, as well as in practice. So with that, let's get right into our program. And I'm very pleased to introduce Dr. Danielle Wyckoff, our first speaker. Dr. Wyckoff is a health sciences practice director for Talk Strategies. She's based in Asheville, North Carolina. And she specializes in using evidence-based methods to evaluate human health hazards and risks that are associated with exposures to a wide variety of consumer products, and that includes food ingredients like low and no calorie sweeteners. Her area of focus is on the use of systematic methods to support risk assessment applications, including the development of health-based toxicity values. So today, Dr. Wyckoff will tell us about the ADI and its derivation, and we'll learn a little bit more about how it can be used to understand the safety of intake when conducting or reviewing research about sweeteners. So with that, we'll turn the platform over to you, Dr. Wyckoff.
Wonderful, thank you very much. Okay, thank you. Well, thank you for the opportunity to participate in this session today. I'm excited to talk more about the ADI and how it applies to low and no calorie sweeteners. I wanted to say a little bit more about my day-to-day and emphasize that I'm a toxicologist and a risk assessor, so a different background than many of you. And thinking about these concepts like the ADI and health-based benchmarks is really part of my turnkey day-to-day process. And I'm going to say a little bit more about what that looks like. Starting with a disclosure for this presentation, there was no external funding provided for the work that I'll be talking about, for the presentation today. Part of my presentation is about a publication from earlier this year, which IFNS was supported scoping review that I'll be talking about. So first and foremost, the definition of an ADI. I want to take a minute to actually read it. This is very important to understand specifically what this represents. So by definition, from regulatory and authoritative bodies globally, the ADI is recognized as the estimated amount of a substance expressed on a body weight basis that can be ingested daily over the course of a lifetime without appreciable health risk. This is typically applicable to the general population, including all age ranges, physiological states, and includes children, elderly, pregnant, and lactating women. Now, the reason that this is somewhat generic and not specific to sweeteners in this instance is because this is a metric that we use all the time to evaluate the potential health risk for food ingredients. Different entities globally have different terms to represent this health-based benchmark, but this concept of defining the level that you can use to screen how much would be safe or without appreciable health risk is something that's very common to our practice. So just as important to understanding what the ADI is also understanding what the ADI is not. And the ADI, first and foremost, is not a bright line between safe and harmful levels. And I'll speak a little bit more as to why that is on the next slide. But it's important not to think about the ADI as a threshold for safety, such that a single exceedance or would automatically associate with a health effect. So really want to establish, again, not a bright line, but rather something to think about as a daily intake that can be consumed over a lifetime. So this slide's a little bit wordy, and I'll walk you through the pictures on the bottom. But what I want to impress upon you is the process as how ADI values are developed and why they're health protective. So these values are developed by scientists and regulators, typically large multidisciplinary teams within these agencies that conduct very large and extensive reviews of all of the available data. So for many of the sweeteners that we're talking about, there are potentially hundreds of studies that are looked at, and these studies might cover endpoints ranging from cancer and reproductive toxicity and genotoxicity, endocrine disruption, etc. So we look at all of that data together. And so if you look at the figure at the bottom of the slide, that depicts, we're looking at a lot of information. Now, from that body of evidence, which usually contains experimental testing in laboratory species like rodents. It would also likely contain epidemiological data in some instances, and then also mechanistic data where we think about things like cell signaling and more cellular events. So again, we're really thinking about the whole picture when we go to say, how do we turn this data into an ADI? And we do that by selecting a study or studies which utilize chronic exposures, so long-term exposures to the given substance. And typically, these studies are done also with very high doses. So we're setting the ADI based on repeated exposure to very high doses in these test systems. And those are what usually forms the basis of the ADI values. Not always. Sometimes a different study type might be picked. Let's say that a reproductive study with a shorter exposure might have been the most sensitive study, and that would be considered. So it's not just duration, but we're also thinking about what's the most sensitive and protective study and representative study that we can use to develop this ADI value. And for that reason, these values are very specific to individual substances. So we're always looking at the data for that specific information in order to develop the ADI. Now, when we're doing this, it's also important to indicate that we're not thinking about potential benefits. So we're not thinking about, in the case of sweeteners, we're not thinking about with the potential nutritional benefits and with weight management, et cetera, when we're setting the health protective value. So coming back down now to the diagram on the bottom, once we have selected that study that's the most protective, we typically pick out a no effect level. So the data set that we're going to base everything on is based on no effects. We then add safety factors to that that no effect level to determine the ADI. So that ADI represents a buffer between the level where there are no effects with an added buffer as it relates to exposure. So how do you use this and how do you help it to interpret exposure? Generally, you compare the ADI to some measure of exposure. And typically what is recommended, there's an estimated daily intake, which represents what you're going to have over time. This is then often can be expressed as a ratio. The concept being, though, essentially you're asking, is it more or less than the ADI? Risk assessors tend to talk about this data in context of margin of safety, MOS, and that ratio helps you to understand if there's the potential for concern or not. If that ratio is over 1, that does not mean there's a health effect. It's something you would go to explore more. Now, one thing I do want to also make sure that I point out is that the risk assessors and different entities globally use different terms to describe this ratio. Sometimes it's margin of safety, sometimes it's margin of exposure, and in some instances, the ratio might be evaluated inverse to what you're looking at now. So you might interpret that number differently. It might be that greater than 1 in that instance indicates the lack of concern. So I wanted to make this point because when you're reading papers or thinking about how to interpret this, it's really the concept of that ratio that you're looking for, and then understanding which one is less or more. So then transitioning this now to thinking about the ADI values for a variety of low-calorie sweeteners. On this slide, I have just listed some of the sweeteners and the actual ADI values shown in the middle 3 columns. Of note, there are ADI values that are developed by different agencies. So you've got the Food and Drug Administration, the European Food Safety Authority, and JECFA, which is a more global WHO perspective. On the very right column, to give you context on the ADI, is the amount of tabletop packets roughly equivalent to the ADI. So going back now to the middle 3 columns, those numbers are expressed as milligrams of the sweetener per kilogram of body weight per day. So when you think about this, we're normalizing this to body weight and to the daily exposure. Another thing to take home from this table is that a number of sweeteners have a lot of information, have been evaluated, if not once, multiple times by these regulatory agencies in order to develop these values. Many of the values are similar or in the same ballpark, which represents also some consistency across the globe in thinking about these safety data. So now I'm going to transition a little bit here to how the ADI values have been used in low-calorie sweetener research. And I'm going to be talking about the approach and the findings, which are reported in an article from earlier this year in BMC Public Health, where the titled "Use of Acceptable Daily Intake as a Health-Based Benchmark in Nutrition Research Studies that Consider the Safety of Low-Calorie Sweeteners, a Systematic Map." I have given the link to this article. It's an open access article if you are interested in exploring this further after today. So our goal with this research was to create a resource for practitioners and professionals to provide information and clarity of how ADIs are used to help interpret LCS research as it relates to achieving nutrition goals. So really what we were targeting is looking at how ADIs were used in nutrition research. And the steps that we took to do that were to identify the information available, to chart the literature, to look at how that literature then evaluated the ADI, and then to publish. So digging a little bit deeper, this was done via systematic or evidence-based methods. This was according to the JBI scoping review protocols. this is all also in the Open Science Framework platform, so you can see our protocol as well as additional information there about this project. Here on this slide, we have the specific review question in the PCC context, so the population concept context. And again, we were looking at how the daily intake levels of sweeteners in human populations were being assessed in context of ADIs. We were very broad in our inclusion, looking at populations of humans in any health status, life stage, or sex. We were trying to take relatively broad interpretations of how the ADI was being used, and we were targeting nutrition research studies. So here on this slide, just a little bit about how much evidence that we reviewed. As you look from the top to the bottom of the flow diagram shown here, you can see we screened approximately short of 2,000 studies, and ultimately included 50 that we knew were very directly relevant and 73 that we were calling contextual. So we looked fully at all of that evidence. So on the right panel here is one of the tables from the study, which just describes the number of publications evaluating each sweetener based on the directional or the contextual evidence. And if you just scan and you see where the highest numbers are, they may or may not be surprising to you on the numbers of publications, aspartame being one of the highest, along with saccharin and sucralose. Some of the studies had very few, likely because of their entry into the market, etc. So this next figure is a little busy, so we'll take a minute here to digest. But what we were showing here is the number of publications per sweetener by year of publication. And keep in mind, this is not just sheer publications on that sweetener, but the publications that utilize the ADI in some way to help interpret or to guide that research. And as you look left to right, there's of course many more publications in the last decade, and in particular the last 5 years or so regarding use of that ADI. The color breakdowns also, the shaded shades of the bar help you to see which sweetener in particular was evaluated. The majority of these increased proportionally over time, with no particular sweetener standing out significantly over time. So we wanted to think about how the ADI was actually being used. So after we looked at all of the evidence, we were able to categorize that data into 4 categories. So I'll talk through them and then I'll explain the figure on the right, which is also a little bit busy to take in that first time. So we were trying to categorize the data by 4 areas, the overall goal of the study being the first, and the population of interest health status, the age, as well as the context of the LCS intake to the ADI comparison. And we can then look at the relationships between those categories as part of a knowledge cluster analysis to see how the ADI is used most in these types of research studies. So the relationship map on the right side helps to join those. So the yellow boxes that are at the bottom of the figure show the health status. The age groups are shown in blue, and then the research study type in red. Then the lines indicate the weights of the number of studies looking at the concatenation of those topics. So the darker the line, the more the frequency of those types of relationships. So for example, this tells us that most often in the evidence base that we drew, the data we're looking at exposure across all ages in a normal population and trying to say what are the daily exposure estimates. We had less information on some of the other population types or the other age groups. So for example, younger ages. So the next figure breaks down a little bit more as to how that ADI was being used within the evidence base. So this just shows a target, if you will, or a distribution of the study categories by research goals. So the gray, which takes up the majority of this chart, were studies which were evaluating exposure estimates. So think about a population doing a consumption survey or some other measure to think about what is the exposure to these low-calorie sweeteners. And so they're rolling that up in various ways, and then they're comparing that estimated exposure, or EDI, to the ADI. So this is a representation of what we would say is the most typical, most common way of thinking about an ADI. And that's because many of these exposure studies were meant to represent what that daily exposure is over time. Then if you look at the more darkly shaded sections, let's start with the darker blue. So about a quarter of the studies looked at the safety or adverse effects and thought about the ADI in context of that. We had a number of studies, and this included both human and experimental animal evidence, where there might have been the context of a potential effect level. So perhaps there was discussion of a specific health effect, and then when talking about the various risk factors or consumption or food consumption type of survey information, that was then being compared to the EDI. So was this effect in this population or the subset of the population, did it relate to sweetener consumption, and how did that sweetener consumption compare to the ADI? We also found a number of studies that were using the ADI as dosage justification. So thinking more about experimental animal studies in a lab, they were setting their doses or their experimental study conditions based on the ADI. This was certainly interesting to us from a toxicological perspective, given that we know that many of the studies that are conducted using guidelines or kind of the gold standard that we know in our industry use very high doses. So it was interesting to also see inclusion of the ADI, which is a much lower dose relatively to often what's used in these types of studies. We then had a handful of studies moving to the lighter blue shades, which looked at metabolism. So thinking more about, these are more controlled exposure situations where maybe a certain sweetener was administered in a controlled trial to understand metabolism and what the metabolites are. So more of a kinetic exploration. We also then had a handful of studies that looked at more at risk benefits. And so they were thinking about both these concepts, the EDI and the ADI, in context of more health nutrition goals. So our conclusions from this study was that we found, when we looked at the literature as a whole, comparisons of sweetener intake to an ADI were really quite diverse. So I think that we found probably more types of applications than we might have expected. However, the majority of those were comparisons to EDIs, which found acceptable margins of safety, no concern, largely, and those represent the most common type of application of how an ADI is typically used or intended to be used. And we also found that while most of the instances of ADI comparisons were really reasonable in the context of each individual study, it is really important that the intake still be assessed and interpreted in a way that is intended by the authoritative bodies. So it's just something that we found it was difficult in some instances to really to understand the application unless you had a good appreciation of what the ADIs represent. So transitioning that to the implications, which will circle back to some of the initial thoughts from the beginning of the presentation, is that from the view of the toxicologist, we really want to make sure that you're keeping in mind the ADI is something, it's the amount of a substance that can be consumed over the course of a lifetime without appreciable risk. And again, it's applicable to many life stages and population types that's considered during the development of the ADI. We also know that the ADI is certainly not a bright line or a threshold. So when you're thinking about reading a study or looking at a report on a website, et cetera, it's important to keep in mind that intended application of the ADI relative to non-traditional applications, particularly those which don't consider daily intake and instead focus on just single day exceedances, i.e. this one time, consumed X amount. That's not necessarily how we usually think about the ADI. It might be a good place to start, but isn't the end of what it wouldn't be the end of that investigation. And we know, particularly for your interest areas, that considering both the risk benefit are very important. That benefit was not assessed as part of the ADI. So this is just something from a practitioner's point of view, you need to keep in mind that there are also benefits associated with sweetener consumption that weren't part of the ADI development. And when you keep these in mind, we really feel like the ADI is a good tool to help think about consumption data or even individual levels of consumption. And with that, I say thank you very much for your attention. I look forward to questions as we proceed.
Excellent. Thank you so much, Danielle. And we will just go into our next speaker and do the Q&A at the end. So I'm very pleased to introduce Dr. Deepa Handu. She serves as a Senior Scientific Director for the Academy of Nutrition and Dietetics Evidence Analysis Library. She has methodological expertise in conducting systematic reviews and quantitative analysis in the field of nutrition. And in her position at the Academy, she's led the development of many systematic reviews and clinical practice guidelines, and she's also conducted research to improve the evidence-based methods that are used for the EAL. So Dr. Handu will provide some practical information on what the ADI means for patients or clients asking about use of sweeteners or products containing them to achieve a variety of dietary goals. So with that, we'll turn it over to you, Dr. Handu.
Thank you so much, Mary. Let me share my screen. Give me a minute. Okay. Let me know if you can. Does that work, Mary? Is it?
Yep, that's perfect. Thank you. Yep.
Excellent. Thank you so much. My talk, like Mary said, is going to focus more on the practice side. You had Daniel talk a lot about the science and how it's, how people have evaluated evidence on the side of ADI. And now we're moving on to what does ADI mean in practice, as well as how do we handle our clients and talk to them about it. So I just wanted to state that I have no conflicts of interest. This presentation reflects my understanding of evidence and the experience in the field. My job at the Academy is with the Evidence Analysis Center. So if you're familiar with that, it's all about synthesizing evidence, putting evidence together, looking at the complete picture of the evidence rather than just one study that comes out and flowing with it. So that's the whole perspective I have when I prepare a talk like that and think about what is the current evidence saying. So let's just dive into the talk. So as a practitioner, when it comes to low or no calorie sweeteners, I think the main things to think about and take into consideration are first the types of low and non-calorie sweeteners out there. There are tons of those, so understanding those. Then thinking about safety, and when we talk about safety, ADIs stand out for low and non-nutritive, calorie sweeteners. And then getting yourself familiar with the scientific evidence and thinking about how do I present all this information to my clients, make it client friendly, not the sciencey information, translating into your clients' education materials. So the first thing, we're going to start off with types of sweeteners. To simply state, we can group these sweeteners as nutritive sweeteners and non-nutritive sweeteners or low-calorie sweeteners. Both nutritive and this low or no-calorie sweeteners are basically added to food to enhance flavor. But there are different types of additions, and we'll talk about them as we go on. The major differences: nutritive sweeteners do provide energy, and the non-nutritive or low-calorie sweeteners add little to no calories. Some of the nutritive sweeteners are naturally found in foods, and the non-nutritive sweeteners or alternatives that add little to no calories in your diet are usually, used to sweeten foods, and they are more processed, or we should say we call them artificial nowadays. People call them artificial or marketed like that. There are a number of FDA approved low calorie non-nutritive sweeteners. So the next set of slides is going to talk about them a little bit. So as I mentioned, there are a number of, and you saw that on Daniel's slide, there are a number of low, no calorie sweeteners that are approved. And, we're going to go through these, but these different LNCS sweeteners, and each of these sweeteners has a very distinct structure and metabolic pathway, and they all provide a very unique level of sweetness as compared to sugar. So basically, based on their structure and how they get metabolized in our body, different sweeteners have different levels of sweetness, and that is reflected in their ADI. And this also influences how they have been used in products. So we're going to see a few of these as we go through the slides. So one thing that stands out is that most of these low or no calorie sweeteners are not absorbed or metabolized by our body, and hence they do not contribute calories. Majority of them don't. Some of them are heat stable, some of them are not. But let's look at an example of aspartame. Aspartame does get metabolized and absorbed in the GI tract, and the products of its metabolism are aspartic acid and phenylalanine and small amounts of methanol. And hence, whenever you look at food packaging or something that has aspartame in it, it does provide a small labeling thing saying people with PKU should avoid it because of the phenylalanine as being as one of the products when aspartame gets broken down. But still, it produces very few calories compared to normal sugar. Okay. Another big one with aspartame was neotame. It came later on. It was manufactured later on. It's very similar to aspartame, has a similar structure, but it's super, super sweet compared to even aspartame. And so we require very small amount of it. And so when the breakdown product over here, the phenylalanine, is so minor in content that it doesn't warrant a labeling for that PKU people should avoid it. Next slide shows you, we're going to talk a little bit about sucralose. Now, sucralose is one of the most used or most sold sweetener out there. It is very stable. Only 15% of it gets absorbed, and none of this is broken down for energy. So there are no calories. Okay. And because it is so stable, it's used in all different kinds of products. It's used in baking and cooking too, because the temperature doesn't change its structure and it maintains its stuff. Then we have other two sweeteners out there, which is the steviol glycosides, which is an extract from the stevia leaves, and the luangwa, which is a monk fruit known as monk fruit. It's from a fruit. Both of them are also pretty stable, and they are used a lot in different products. So the reason of these two slides showing you is that figuring out, when you look at the low or no calorie sweeteners, figure out how they are metabolized in the body, what do they get broken down to, and their structure basically determines how stable they are going to be. So based on their stability, they're used in different products. The other big thing with low and no cal sweeteners is the safety, and that's where we come about ADI and Daniel spent, some important information about ADI in research. But what does it mean for us as practitioners? I think we need to realize that LNCS sweeteners are thoroughly tested and carefully regulated by FDA in US for approval to use in foods and beverages. The ADI is the amount of an ingredient that a person can safely consume every day over a lifetime without risk. It is an extremely conservative number to make sure that there is no harm. Now, and the other thing to remember is that due to these all differences in the structure and metabolic pathway, these LNCSs have a different level of sweetness, and this is taken into consideration when they develop ADIs. The next couple of slides are going to show you a list of sweeteners with their brand names and the level of sweetness compared to sugar, and then you'll notice that the ADIs for each of them is a little different, and the differences come from the previous two slides, that is their structure, how they're broken down, and that reflects in this table. Daniel had a similar kind of a table, but over here what I have is most of your clients are not going to know what kind of LNCS do they consume. What they know is what are the brand names that are selling them, because these are the names on the packets everywhere. So this kind of connects your clients with the sweetener they're consuming. It also reflects over here on the table is translating their sweetness of each individual LNCS with the ADI into the number of tabletop packets that one can consume. And I think this is becoming more and more critical as nowadays the low or no calorie sweeteners are widely present in a lot of different types of foods, medications, personal care products like toothpaste, and food and beverages for sure. So reading the ingredient list becomes very essential. Informing your clients about the names of the sweeteners, the different names it might be called out in literature or used on products, making them familiar with those, as well as the brand names, and then giving an idea of the sweetness of each one of them. Because they're so intensely sweet, if you look at the third column, it says how sweet they are compared to the sucrose or table sugar. They are needed in very little quantity or amount, and sometimes people just take so much of it and then they get used to taking that much. So I think they don't need that much. That's another key thing. So nowadays, with the focus being on organic, going natural and everything, we do hear different terms popping up when it comes to sweetness too. Okay. So the big debate is natural versus artificial sweeteners. We do have three kinds of sweeteners going around. One is the natural nutritive sweeteners, which is basically honey, dates, some nectars that are out there. But remember, they are also processed. They're not all of them are natural. Some are natural, but some can be processed. So keeping your eyes out for that. The low, no calorie sweeteners, the goal was when they were developed was to add sweetness without calories. Okay, so they do provide a some of them provide small amount, or some of them provide no calories at all. Okay, but they are way more sweeter than sugars, and so you need less of them. Then others we have are the naturally occurring sugar alcohols, which are present in fruits or vegetables, but they can also be manufactured. So what's happening is out in the media with so much text going on, the line between artificial and natural is a little murky. Most of the sugars in processed foods, soft drinks, and other foods are made from complex processed sugars. They might be primarily some form of sucrose, and most of it is derived from high fructose corn syrup. So keeping that in mind too, that processing is out there a lot. On the other hand, there are other sweeteners like stevia, which is a low to no calorie sweetener. It's becoming very popular right now because it is derived from a plant or a leafy herb. Okay, so and it's available everywhere. A lot of foods are putting them. It's been used in an alternative sweet in a lot of different food brands out there. So it's becoming very popular. And similarly, monk fruit is another natural because it comes from a fruit. It's becoming very popular. But that's true to an extent that they are natural. But to make them consumable or put into food groups, they do get processed a little bit. So keeping that perspective in your thoughts when you're talking about artificial versus natural sweeteners is very important. Both stevia and monk fruit are marketed as natural alternatives to sugar, And so they could be true to an extent, but they have to be converted into a form that is stable and that can be incorporated into liquid foods or solid foods or confectionery foods. So all of them do undergo a little bit of processing. This slide also shows you the potential benefits and harms of each kind of sweetener. I think the key to know is that both natural and artificial sweeteners are used for the reason of making your food kind of sweet. The biggest pro of artificial sweeteners is doesn't contribute calories. Okay, so specifically for some groups like people with diabetes or people who are trying to lose weight, it can help reduce calories. The biggest pro of the natural sweeteners is it's easy to metabolize in your body. It adds some nutritive value, not significant, but some of them do have vitamin and mineral, or some of them have some enzymes that might be helpful. And the biggest con of the naturals one will be empty sugar calories, and it could be processed, not totally natural. For the artificial, the biggest con is it does not offer any other health benefits, and then taste. Some of them have aftertaste. And when it comes to clients, it's all about what works for them. They might, if the taste is good, they might go with it. If the taste is not there, even if you explain the health benefits and everything, it might not work for them. So taking all those things into consideration is really important while talking to your clients. So let's switch gears and now talk a little bit about, so what does the evidence say? Okay. At present, based on evidence, low or no calorie sweeteners are safe and they're approved by the regulatory bodies. They are some of the most researched and studied food ingredients. However, we still kind of debate the long-term effects of, health on health, and we warrant more good quality research. I do put the emphasis on good quality research, as it is conducting research in the field of nutrition and figuring an out impact of a dietary pattern or impact of one ingredient is not easy. So in the field of low and no calorie sweeteners, it gets more complicated. At present, the evidence from some RCTs, it clearly suggests, and cohort studies does suggest some beneficial effects when it comes to reduce energy intake and body weight. Okay. When it comes to fasting blood glucose levels, the results are mixed right now. Some studies are showing impact, some are not. When it comes to appetite, again, based on current evidence, there appears to be no effect. And now the new topic of interest, which everybody's really, all fields of nutrition are interested in, is gut microbiota. So the current available evidence does not verify any adverse effects, as well as it's not showing any great positive impact too. And this field of data is very limited. So it does require further research. So overall, even with so many studies getting out over there and people publishing, the information from good quality and long duration studies is still missing. Hence, it takes away the confidence from us to say, hey, this is going to be detrimental or this is amazing. We do not have the confidence in saying that. The evidence is still pretty mixed. Another big, I just want to mention one more thing because we're talking about nutrition research and we know it is so fuzzy and complicated because so many variables play a part. So another big thing in some of these studies we have noticed is something called effect modification. That means the existing unhealthy diet. Let's say a person changes just one ingredient, sugar sweetened beverages, and starts taking LNCSs. Okay, but the other thing stays same. The dietary pattern is, not the most amazing still. They follow what they were doing. Are you going to see some impact? Most likely no. So there are a lot more variables that need to be taken into consideration, and I hope the research studies that come forth look at all these confounding variables that have an impact. So when there's so much buzz about evidence and still people have some concerns about what's going on, the recommendations are out from other health related organizations. So there are a number of organizations that have developed guidelines or some recommendation statements to help people make a decision about LNCSs. They all have a little different take on the message, as they're addressing different populations. Some are children focused, some are general healthy people focused, some might be focused on comorbid populations. And also the approaches that a guideline developer takes could be a little different. Some might be based on systematic reviews, which are the highest standards of evidence, and some might be based on just comprehensive narrative reviews. So a little bit differences are there. However, the bottom line is that replacing added sugars with LNCSs can reduce calorie intake in short term and aid in weight management. Yet the questions remain about the effectiveness in long term weight management. Most of the organizations say that LNCS beverages, they will be or may be a useful replacement strategy to reduce intake of sugar sweetened beverages is. And that is one of our problems in US, is that we had very high intakes of added sugar, and sugar sweetened beverage consumption was very high. That's the whole push for these non-nutritive sweeteners came into picture. Okay, so we do see benefits with them. They also discuss the scarcity of data when it comes to children and adolescents. So the data in terms of long-term benefits is scarce, and it's pretty complicated. So we do not know how it's going to work with kids in the long term. We are talking about short term, we are seeing some impact, but in the long term, we do not know how it would be. Do we still think water is the preferred beverage? Yes, it is. But we know there are tons of people out there who love their sugar sweetened beverage, or who love sweetness in their food and everything. So are they a good option or not? I think work with an individual and figure out. They do have some pluses. Low or no calorie sweeteners do have some pluses for people like that. So figuring out a balance of what will work perfectly for a client, working with them, and taking their response into consideration will be really helpful. So moving on a little bit more into practical side of it. While science behind non-nutritive sweeteners is an important part for how RDNs can prepare themselves to help their clients, understanding how these sweeteners function and how their taste is vary can help one guide, to make an appropriate choice for their patients. The LNCSs differ in their activation of different types of taste receptors. Some of them are sweet, bitter, like stevia or the steviol glycosides. They have a little bit of a aftertaste. So how they started making products and how they started improving that taste was by mixing them with erythritol, which is an sugar alcohol. So the mix of both of them was amazing, and it replicated the sugar taste so well that it became one of the good sellers, and people's acceptability of it is high. So there have been some, figuring out what works the best is important. Different properties when used for different applications, keeping in mind, are you baking with it, or are you going to just put it in a drink, or it is in a drink? All those things are important. So going back to the previous two slides of their structures, how they're built and how they get broken down in the body impacts this their how they will be used. And always work with your client to understand. I think those people know way much better than me, who work in the field with clients day in and day out. So the take-home message from this slide about evidence is, do not base your opinion on one single study, which is the single study syndrome we call in research. Take into consideration more evidence. FDA has reviewed evidence over the years to determine the safety of LNCS. You can vet that evidence. You can see what's the new evidence that has come out recently. So critically evaluate the study of the day. If there's that one study which provides some amazing like a con or a pro study, any study it could be, but evaluate it. Look, the key things to look for: is it an animal versus human study? There's a big difference in sweet preference and reactivity to sugar between a mice and a human. Okay, so there is a difference over there. Population of the study: are they using healthy people, overweight people, people with diabetes? So paying attention to those things, paying attention to whether it's an epidemiological study versus a clinical trial. Epidemiological studies rely a lot on self-reported data. So keeping those things in mind, then keeping the dose in mind. Some of the studies showed adverse effects were getting way above ADA doses. Okay, so those are some of the core things to keep in mind. This slide just is bulleted things that you should take into consideration. I'm not going to read through that, as we have gone through some of them, but the key thing is ADI, Are they approved or not? Do they meet your client's need? And what are the restrictions for some special populations? This slide shows you a little bit of understanding the ADI, how you can make your clients understand. And we know ADIs are set by FDA, and how do you translate them? So to get an idea of how much of a sugar substitute may be consumed without adverse effects, consider the following example could be used, that a 132-pound person could consume so many packets to reach there. You really don't want them to be there, but just giving them an idea. And another example of aspartame is given over there. These are just sample examples you could use with clients. And another big thing is that foods may naturally contain the same substance as your sugar substitute, and sometimes it could be in greater quantities than the sweetener itself. So understanding the sweetness components and the natural foods component. Very good example is a non-fat milk, 6 to 9 times more phenylalanine, okay, in some more aspartic acid, which is way more than aspartame. So keeping these things in mind too, while counseling, bringing the picture together of sub, additional stuff versus yourself. Um, some of the client tips, I'm keeping time in mind, so going a little faster, but the client tips, if your client is a sweet liker, make sure, a good solution could be replacing some of the high sugar foods with this. Also, they can help cut calorie and very little amount is required, okay? Make people, clients aware of that. Please read the ingredient list, which I know all of you do, just bringing it back to it. And it's just that sometimes even foods that are considered healthy, diet foods, can contain these sweeteners. Also, if you think the client or an individual is appearing to exceed the ADIs regularly, then there's a real problem and you need to start intervening by reducing some of the very, very simple things, first is diet sodas, okay? And also then sweetened yogurts, which people forget sometimes might have. The clients do, not our dietitian friends, but the clients do forget. So reminding them of some small changes. So the bottom line is that sugar substitutes are widely consumed and are present in a variety of products ranging from grains and dairy products such as in some breads, yogurts, soft drinks, condiments. So a survey was conducted in US and it indicated that as many as 25% of children and more than 40% of adults interviewed do consume these sweeteners. And according to, and another big thing that came out of the survey was that they were using them on daily basis, which just shows that how common sugar substitutes or alternatives are in our diet. So hence we cannot ignore them and we need to vet the quality of evidence that is out there, as well as intervene and help them make better choices even among the low calorie sweeteners, as well as making them realize that there's a limit to these too. It's not a magic bullet. It's not gonna, you know answer all or solve all your problems. Still, the whole dietary pattern and the whole picture needs to be taken into consideration. This is just one part of it. So if you were just going to ask about, evidence, yes, current evidence and guidance from FDA does support their safety when it's consumed at a level within the ADIs. Most of the organizations that have recommendations out there always said that if it is within the ADI, we haven't seen any issues. Like Academy's guidelines, which are a little old with gestational diabetes and with people with diabetes, and the use of these sweeteners was that they could consume it and make it a part of their dietary pattern. But there were X, Y, and Z considerations. And then the main thing was they should be within the ADI levels. I think that's all I have for today. Thank you so much for your attention.